This is Geometry, Unit 11, Lesson 3, on arc length and the area of a sector. Now, arc length is the actual length of an arc. In centimeters, and it can be inches, it can be feet, or whatever. It is not the same as the degree measure of an arc. So if I'm looking at this circle right here, AB right here is an arc. That right there is an arc. So if I wanted to find the length of the arc, I'm looking at the distance from A to B. The measure of the degree measure of the arc is the angle, central angle that the arc makes. So 60 is the degree measure of the arc. AB is the arc length. Okay, so just because you have the same angle here does not mean that the arc length is the same. Arcs AB and DE, these two arcs right here, have the same degree measure. They're both 60 degrees, but they are not the same length, obviously, because even though they're not congruent because they don't have the same length, they're in different size circles. So this arc is larger than this arc, even though the angle measure is the same. Okay, so what we're going to look at, now that we know what arc length is finding how to find what arc length is. To find arc length, we want to set up a proportion. We want to compare the part to the whole of what we know for each circle. So let's take a look at what we know part to whole. In a circle of radius 8, find the length of an arc subtended, or cut off, by a central angle of 70 degrees. So let me draw my circle. I have a circle drawer so I can cheat. Here's my circle. Okay? And it has a radius of 8 centimeters. So I'm going to draw my radius in here. Is going to be 8. Okay? Find the length of an arc subtended by a central angle of 70 degrees. A central angle is an angle created by two radii. So the angle right here is going to be 70 degrees. Notice it's called a central angle because it goes to the center of the circle. Okay, now what we're looking for is the length of this arc. Okay, so what we need to know is to figure out the part and the whole. Okay, so this sector, that's what this is called, the arc intercepts an angle of 70 degrees. That is part of how many degrees total. All right, well, if we do part to whole, it would be 70 degrees out of the total degrees. How many total degrees would that be? It would be 360 degrees. All right, so 70 degrees is to 360 degrees. Okay, now, what we're looking for right here is the arc length. Usually that's called S. I don't know why, but it is. All right, so we're looking for arc length. Is the arc length a part of the circle or the whole circle? It would be a part. So it would be S over the whole way around. Well, if we're going the whole way around here, what would that be? That would be the circumference of the circle. All right, so that would be the circumference. Well, how do we find circumference of a circle? It's 2 pi r. Or you can do pi d, but we have r, so let's use r. Okay, so this is a part. This is the arc. That is a part. And 2 pi r is the circumference, or the whole part of the circle all the way around. This is the sector angle measure. This is the whole. All right, so it's part to whole equals part to whole. Okay, so let's plug in what we know. We know 70 is to 360 as S, we'll just leave it as S, over 2 times pi times r in this case is 8. Okay, so simplifying a little bit, I'm going to leave this in terms of pi for right now. So 70 over 360 equals S over 2 times 8 is 16 pi. All right, so what do you do when you have a proportion? You cross multiply. So let's cross multiply. 360 times S, I'll make a little better S there, is equal to 70 times 16 pi. And then, so to solve for S, we would have to divide by 360. So S is equal to 70 times 16 pi divided by 360. All right, so all we have to do is go to our calculator, and we're going to round this off. So I can multiply this out if I want to. 70 times 16 is 1120 pi over 360, because these all multiply together. All right, I'm going to put this in my calculator and round it off. All right, so we have to do 1120 pi, use your pi key, and then divide it by 360. So the length of that arc is approximately 9.77. So that's approximately 9.77, and we are in centimeters. So it's 9.77 centimeters. So that's value right there. Okay, so what we're basically doing is setting a proportion comparing the angle measure part to the part of the arc that is part of the circumference. Okay, let's try another one. In a circle, an arc of length 25 inches has a central angle of 100 degrees. Find the radius of the circle. Okay, so I'm going to draw my circle. Here's my circle. It has an arc length of 25 degrees and 25 inches and a central angle of 100 degrees. Okay, so I'm going to make my central angle look something like this. It's going to be 100 degrees. And I know this value from here to here, that arc length right there, is 25 inches. Okay, and we are looking for the radius of the circle. Okay, so in order to figure this out, we have to compare the angles, which would be 100 out of 360. All right, now the arc length is the part of the circumference. So that's going to be 25 over 2 pi r. Because we're looking for r, we have to leave it as r. All right, now when we cross multiply, we get 100 times 2 pi, right here, 2 pi r actually, is going to be 200 pi r. Is equal to 360 times 25. 360 times 25 is 9,000. Okay, now to solve this, we have to divide by 200 pi. All right, so 9,000 divided by 200 pi. Now notice I'm putting this in parentheses because if you want to enter 200 pi in your calculator to divide it by, if you don't put the parentheses, it'll do 9,000 divided by 200 and then multiply it by pi. So you have to use the parentheses here when you enter it in your calculator. So that would be 9,000 divided by 2, whoops, I forgot my parentheses, got to do my parentheses, 200 pi. Okay, so that's what we want, enter. Now, if you do this without the parentheses, this is why. 9,000 divided by 200 pi, notice we get a different answer. So make sure that you use your parentheses. So this is going to be approximately 14.32, and this is going to be in inches again. So r is 14.32 inches. So its part is to whole as part is to whole. Compare the angles and compare the circumference. All right, let's do one more of these. In a circle of radius 20, what is the measure of a central angle that subtends an arc of length 6? Okay, so we're going to make a circle. It has a radius of 20, so I can draw a radius of 20 right there. Okay, and we're looking for, the arc length is 6, which would be right here, and we're looking for this angle right here. And usually theta is angle, so I'm going to use theta as my angle. All right, so I need to know what my central angle is. All right, so that's what I'm looking for. Theta out of 360. This angle out of the whole is equal to the arc length, which would be 6, out of the whole circumference would be 2 times pi times r, which would be 20. Okay, so theta over 360 is equal to 6 over 2 times 20 is 40 pi. All right, when you cross multiply, you get 40 pi times theta is equal to 360 times 6, which is 2160. Okay, because we cross multiplied here and there. All right, now to solve for theta, you get theta equals 2160 divided by 40 pi. Now again, put the 40 pi in parentheses when you divide it. So we get out our calculator, 2160 divided by parenthesis 40 pi. And rounded off, it's approximately 17.19. This is an angle, so it'll be 17.19 degrees. Okay, so that is arc length. Now we can also do the area of a sector the same way. Now first of all, what is a sector? A sector of a circle is the region between two radii. It's like a piece of a pie. So this right here is a sector because this is a radius and that is a radius. Both of those are radii, and it creates what's called a sector, or a section of circle. Think of it as cutting a piece of pizza. All right, so to find area of a sector, we set up a proportion. Again, its part is to whole, equals part to whole. So again, we're going to be comparing the angle that's cut off to the whole, but this time it's going to be a little different for the part if we're doing area. So let's take a look at that. All right, so here's my circle. Find the area of the sector of a circle of radius 8 feet. There's 8. Having a central angle of 40 degrees. All right, so there's my central angle of 40 degrees, this angle right here. I want to know the area of the sector, so I'm looking for this space right here. That's what I'm looking for. All right, so we want to compare part to whole. We know the angle measure, so if it's 40 degrees out of how many? It would be 40 degrees out of 360. Okay, now we are looking for the area of the sector, which I'm going to call A, which would be the area of the sector. That area of the sector is a part of the whole area. What's the formula for the whole area of a circle? Well, it would be pi r squared. So this is the sector area, and this is the whole area, because we're looking for a part of the whole. Okay, so it's 40 over 360 equals A over pi times 8 squared. Okay, so that's going to be 64 pi. 40 over 360 equals A over 64 pi. All right, so all we do, same thing, cross multiply. We get 360A is equal to 40 times 64 pi. All right, and 40 times 64 pi is 2560 pi. Don't forget the pi. And to solve for A, we have to divide by 360. So 2560 pi divided by 360. So I go to my calculator. 2560 pi divided by 360. And it's approximately 22.34. Now, since this is an area, and this is in feet, area is in square units, so this is going to be 2234 square feet. So that is your answer. All right, let's do one more. A circle has a radius of 15. Here's my radius. What is the central angle of the sector? So we're looking for theta. That has an area of 200. Well, let's figure it out. Part is theta out of the whole degrees would be 360 degrees. The area of the sector is 200, and the area of the whole would be pi times 15 squared, because that's the whole area. So it's theta over 360 is equal to 200 over 225 pi. Okay, 15 squared is 225. Cross multiply, you get 225 pi times theta is equal to 200 times 360 is 72,000. All right, so theta is going to equal 72,000 divided by 225 pi. Now again, make sure that's in parentheses when you put it in your calculator. You'll get the wrong answer. All right, 72,000 divided by parenthesis 225 pi in parentheses. Make sure it's in parentheses or you're going to get the wrong answer. Enter. You get approximately 101.86, approximately. And since this is theta, it's an angle, it's in degrees. So basically when you're doing the area of a sector or the length of the arc, you are comparing the part to the whole using either the circumference or the area formula.